It's still the same formulas though. Okay, so in the first, let me open it up here for people. Version 2. Okay, so what they have here is this is a battery, and it's 12 volts with internal resistance 1.6 and then an external resistance here. So what they want you to do is copy this table and put in the numbers. So here, total resistance. And look, they even tell you the formula. Add 1.6 to OR. So here's OR, and here's 1.6. So what's the total? Add them together. So I'd like you to fill this table in, please. So here would be 3.1 and so on. So can you just do this row here to the diagram? I'll make the table here too. Okay. Do you have the numbers written down? So just call out the numbers on the top for me, please. It starts off with 1.3. So OR equals 1.3, 3.1. No. Was it 3.1? No, it was 1.5, 1.7, 1.9, and 2.1. Yes, top one. And now, next one, the total resistance. Okay, so now, Joshua, that's the numbers I was looking for here. 2.6, or 2.9. Next. Next. 3.1. Next. You're just adding 1.6 each time.
3.3.
3.3. 3.5, 3.7, and that's it. Okay, the next part here is the current. So what formula gives us current? We could use what? Yeah. Do you know the V?
Yeah, 12.
12. Do you know the OR now?
Yeah,
Yeah, that was what you just worked out. So we want the current now. Okay, so current. And you're using the formula V equals I OR. So I is V over OR. So that is V, which is 12 divided by OR. So what did you get first? Yeah. You have these numbers. Okay. Next, the potential difference, V equals I OR. So the voltage across which one? Across the big resistor or the total resistance? No, the big one. That's that OR up there. Yeah, so it's voltage multiplied this OR. Voltage is this OR. So I, which we know, and the OR, which is just the top numbers here. So voltage in OR. V equals I OR. Here's the I, and then here's the OR. Multiplying them, there's all the voltages in the resistor. Okay? And then next is the power. Power equals IV. Power, which equals IV. And which power is it? The power in OR. So the power in OR is the current in OR, which is there, multiply the voltage in OR, which we just worked out. So there's the powers. That would be nice, wouldn't it? How many marks for that table? 4. And then what do they want you to do next? They want you to plot a graph of power against resistance. Okay, so now they want a graph where you have power against resistance. So the R is on the x-axis, and then the power is on the y-axis. So the different values of R are 1.3, 1.5, 1.7, 1.9, 2.1, and then the powers is that one, and then there's the next one, and then there's the next one, and then there's the next one, and then there's the last power. So they would like you to put this in a graph. So I'll do that now. Insert, chart, XY. Now I have a feeling that it actually will be a kind of curvy shape. So I'll go for this one with smooth lines. Okay. Now what's on the x-axis? Resistance in, what's the unit? Ohms. And what's on the y-axis? Power in watts. And the title, I'll just call it my graph for now. Get rid of the legend, put in the x and the y. There we go. So you should get something like this in the exam. Now, how many marks for making that graph? How many marks? 8 marks. So how many do we have so far? 12. Okay. Oh, actually, it's more than 8 marks, because what's the next part? Part 3. Join the points on the graph with a smooth curve. So 2 points. Do you see that? So now, how many marks do we have? 14. Okay, what's the next one? Read off the value of R that gives the maximum power. So where's the maximum power? It's around about here, isn't it? So what R gives me maximum power? 1.6. No, but hang on. 1.6. Does that sound familiar? Where did we see that? 1.6. Yeah, it's internal resistance. And do you remember when we did this, I said the best external resistance to use is equal to the internal resistance. And you can see in the graph, you get most power when you use a 1.6 resistor. Okay, so 1.6. What's next? Oh, comment. So what is the comment? I just said it. Yeah, maximum power when the external resistor equals the internal resistor. How many marks have I gotten so far?
A lot.
18 marks. How much work did I do?
Nothing.
Sweet all nothing. Yeah. Now the last one is what value of resistor should be connected in parallel with a 5.12 resistor so that the combination is 5. In other words, how do you add 2 resistors together to make a 5 if one of them is a... Yeah, so you have to use the formula for combining the resistors. So what formula, are they in series or parallel? Parallel. So it's 1 over x plus 1 over 5.12 equals 1 over 5. So then x would equal 1 over 5 minus 1 over 5.12. What's x, please? Did you type that in? You know, you do the same thing for Lorraine, and it annoys her too, just like me. If you have a calculator, use it. Don't just guess the answer. You got it? Oh, it's really not 4 points, whatever you just said. Can you go ahead, Daniel? What did you say?
113.3.
20 marks. Not so bad, huh? I mean, that was great for 20 marks. Any other electricity ones? Oh, yes, there is kind of a capacitance question there in number 6. But we won't do that just yet. Can you go to page 95? 95, please. 95, yeah. So we're going to look at one more question. This is year 2006. Version unknown. Version 2. And it is the last question. Okay. When a capacitor discharges, here's the formula for the voltage. Well, we know that one. We did that one yesterday, didn't we? Show that a graph. Okay, so in other words, it was the little proof we did in class. Make this a linear graph. So what would you have to put on both sides? Log. So just try that now for me. Make this into a linear form. Okay, I'll write it up now.